Hello, chemistry students. It's Ms. Osterberg here. We're going to go over the grams to grams worksheet 2. We're going to be using this equation up here for everything that we do. So this one right here. Okay. So we're going to start with the first. It says a student starts with 30 grams of carbon. So this is what we have. And it wants to know, so this is what we have. We have 30 grams of that. It wants to know how many grams of iron 2 oxide we're going to need. So this is what we want right here. So we have 30. We want to know how many we have of grams of iron 3 oxide. So we need to get our grams into moles, because moles is the only way that we can go from one chemical, such as carbon, to another chemical, iron 3 oxide, using the 3 and the 2 for the mole ratio. So it's going to take us 3 steps. And I have shown you here how to do this. So the first thing we're going to do is we're going to convert the 30 grams of carbon. We need to put that into moles. So from the periodic table, we know that 12.01 grams of carbon is equal to 1 mole of carbon. And that's going to come out to 2.50 moles of carbon if you round to 2 decimal places, which is the hundredths place. Now we're going to take our 2.5 moles of carbon that we have. So up here, 30 grams of carbon is actually 2.5 moles of carbon. And we want to know how many moles of the iron 2 oxide we're going to have. So using these numbers up here, we know that 3 moles of carbon, we're going to put that in the bottom so that carbon cancels, is equal to 2 moles of our iron 3 oxide. Sorry about that. And if we take 2.5 times 2 and divide it by 3, we're going to get 1.67 moles of the iron 3 oxide if we round to 2 decimal places. So our last step, because we want grams right here, our last step is going to be to get our 1.67 moles of our Fe3O2 into grams. So from our periodic table, we know that 1 mole of Fe iron 3 oxide is equal to the molar mass of that. So on the periodic table, you would add up 2 irons, which are 55.85, and you would add those to 3 oxygens, which are 16, and that's going to get you 159.7 grams of the Fe2O3, and that comes out to 266.70 grams of Fe2O3. So if we have 30 grams of carbon, we're going to get 266.7 grams, or we're going to need 266.7 grams of Fe2O3. Okay, so that's how you solve that first problem. I'm going to erase this. The next problem we're going to do, so same thing, we're going to use the same equation. It says a teacher reacts 10 grams. We'll do it a different color. A teacher reacts 10 grams of the Fe2O3 with excess carbon. So excess, if we go down here, it means that we have a ton of that chemical. So if you look up here, we have 10 grams of this. We have lots of this. And the reason why we put that there is because next week we're going to figure out which one will run out first. And so it's just proper to write that there's lots of this. So whenever you see excess of something, you can just ignore it. We don't care about that. Just ignore it. So this says a teacher reacts 10 grams of iron 3 oxide. What mass of iron will be produced? So this is what we have. And this is what we want, is the iron. So again, we're going to need to do the 3 steps. So the first step is we have to get the grams of the iron oxide into moles, because moles is the only way that we can get to the other chemical. So again, luckily we know the molar mass of this. It's 159.7 grams. And we know that's equal to 1 mole. And so when we do that math, we get 0.06 moles of Fe2O3, which is awesome. So now we know we have 0.06 moles of Fe2O3. So now what we're going to do is we have 0.06 moles Fe2O3. Now we need to get it into the other chemical, which is iron. So what we want over here, we want iron. Well, let's go up here. We have 10 grams of this. We want to know how many grams of this we have. So this is a 2 to 4 ratio here with the moles. So we're going to go down here and we have 2 moles of the Fe2O3 and we have 4 moles of the iron. So that cancels. So 0.06 times 4 divided by 2 is going to get us 0.12 moles of iron. And then our last step is, and I'm just going to put it over here to save room, is we know that 1 mole of iron is equal to 55.85 grams of iron. We know that because of the periodic table. If you look at iron, which is number 26 on the periodic table, you'll see the molar mass is 55.85. That's where we're getting that number. And when we do that math, we get 6.70 grams of iron. Okay, 6.7 grams of iron. So up here, if we had 10 grams of this and we had lots of this, we would need 6.7 grams of iron, or we would get 6.7 grams of iron. We would produce that. All right, last one. Last one. We'll go green this time. Okay, so this last one right here, we are in lab and we have 0.47 grams of carbon dioxide. So this is what we have. How many grams of iron will also be produced? So this is what we want. So we have 0.47 grams of this. We want to know how much of this, how much iron is going to be produced. Okay, so let's go down here. We're going to start with 0.47 grams of CO2. First step we have to do is to get it into moles. So we always get it into moles first step. So based on periodic table, 1 carbon and 2 oxygen is 44.01 grams. And that's equal to 1 mole. And this is going to come out to 0.01 if we round to 2 decimal places. And that's mole of CO2. And then we're going to take 0.01 mole of CO2. And we need to get it into the other chemical because we need to get it into iron. So we're going to look at the mole ratio up here of carbon dioxide, which is 3, to iron, which is 4. So we're going to go down and we're going to do 3 moles of CO2 to 4 moles of iron. And when we do that, 0.01 times 4 divided by 3, when we do that, we get 0.01 again. This is moles of iron. So now we're going to take 0.01 moles of iron. And our last step is to get it into grams. So 1 mole of iron, based on the periodic table, is 55.85 grams of iron. And that's going to equal 0.56 grams of iron. So if we produce 0.47 grams of CO2, we're going to produce 0.56 grams of iron. And that's how you do these 3 problems. So it's always 3 steps. You always convert what you have of grams into moles. So grams of have into mole, and then mole of have into mole of want, and then mole of want into gram of what you want. Always 3 steps. 1, 2, 3. Every single time.